The point of Web3 is in some sense to transcend beyond national boundaries and create a system of law, digital law, fit for a global nation. You shouldn't wait for technology to be delivered to you in a product form, but kind of like with education, you need to go out and you need to seek. The current Polkadot protocol, the expertise is really very concentrated, centralized, you might say. It's my fault for not making a big enough effort to help others understand the protocol. And so one of the sort of main changes of approach with Jam is really to try and decentralize the expertise of the protocol, technical and intellectual decentralization. It's not something you see very much in Web3 protocols, really at all these days. And Polkadot is not the worst of them in this regard, but it's also not quite up to the sort of Bitcoin and Ethereum 1 level of intellectual decentralization. And with Jam, I'm really hoping to move it into that sort of family of protocols.
Hoy Buenos Aires se convierte en el epicentro de la tecnología con la llegada de Gavin, pilar de la innovación digital, para desvelar el Great Paper de Jam.
This is a formal specification. It's not a vision document per se, in the same way that the Polkadot paper was a vision document, didn't have very many details in. This is fully detailed, and from this document, it should be possible to implement this protocol. Jam is a little bit like a marriage of Polkadot and Ethereum. It takes some elements from both. In particular, it takes the sort of scaling machinery of Polkadot and marries it into more of a Ethereum-like paradigm.
By trying to take it to many different centers of learning around the world, I hope to really make many more people familiar with the protocol.
And a core is a logical construct that does computation, a little bit like a regular CPU core, but spread out across a network of nodes. Jam has, for what it's worth, 341 cores.
It's a formal specification, which means I'm using set theory, basic like formal maths. And so part of this Great Paper Tour is to go through each formula and actually try to re-understand it with people around.
But then actually the final value, beta prime, is informed additionally by a few other terms.
And see if anyone brings up any important points that need to be addressed.
I would like you to explain a little bit more about the difference between services and smart contracts. The way I see it, services are like smart contracts in Jam, but they can also access part of the pre-image information.
Basically, we take what would normally be a single piece of code, and we split it up into two parts. One part is called refine, the other part is called accumulate.
One of the reasons that Argentina, of all of the Latin American countries, is the one that chose to make the Jam lecture in, is that people are really very interested within Web3 technology for the right reasons. When I say the right reasons, I don't mean like, speculation on crypto tokens or anything like this, but I mean actually trying to use the token to solve real world problems. And I think part of this is because Argentinians actually have real world problems to solve.
Argentina is a place where there are many financial problems and people are very enthusiastic about using new technology. So if you actually bring a technology that is really cost effective, like we believe Jam will be, it will really make a difference.
What Jam introduces is the possibility of really scaling the blockchain, where transactions and scalability is not a problem for adoption.
We have the knowledge, we have the capacity. I think we should be able to help Jam.
We are not only great computer scientists, but also we have the motivation to make this a reality and help it grow.
For all the developers present here, what would you say to them in order to encourage to collaborate on the building of Jam and make it a reality in the future?
it's not that complicated, and I really want to make this thing implementable by, coders, by regular people, not teams of 15 that have already implemented Ethereum twice. And I'm trying to structure lots of incentives to make it worth people's while. It's certainly, in my mind, worth Polkadot's while to try and get as many separate development teams implementing its protocol as possible. But this is why we've got the implementation prize.
The Jam Prize is really there to try to bring people into this environment and incentivize them for delivering important milestones in the building of an implementation. There's a 10 million DOT and 100,000 KSM, so it's in the tens of millions, and each team will get up to 500,000 DOT and 5,000 KSM. It's the sort of size that I would hope allow people to sort of take the risk, that spend their own time actually building something. And I would hope it's also this kind of size of prize that gets some academic institutions interested as well.
I don't think there was a particularly significant amount of take-up.
Yeah.
Vitalik and I were here the first time. There certainly wasn't in Silicon Valley in general.
So you guys met several Silicon Valley VCs as well for the fundraising.
Yeah. But no, they were interested. I mean, it would have been an excellent investment if they'd actually done it.
Yeah.
They were interested.
And now you're invited by the Stanford.
Yes. My hope is that this is still based on what I have to say, and less based on who I am and what I've done before.
So, jam, how does it look? It's kind of this funny flower shape. So basically like a bunch of petals with this middle core. The numbers seem a bit, outlandish, and we're sort of talking a factor of 1 million. Essentially, the petals function as huge, powerful, beefy preprocessors that take the external data of the system from the world, preprocess it in some way, and then feed it on into the middle, into this melting pot. While big unions, like the US, tend to manufacture their own trust, I think increasingly in the modern world, this is becoming questioned. I hope Jam will be the blueprint protocol for what will be a very scalable, trustless computation platform, Web3 platform, and be part of a solution that reduces those concerns. I think we can see, let's say, very hybrid systems forming in these sort of superstate entities, whereby the foundation is a classic Web3 sort of blockchain, but we have very clear, strong providers of last resort, perhaps run by national governments or licensed institutions, that can, under the rules enforced by the blockchain, help provide services like things like voting procedures.
The issue with the Stanford talk was that it was only 50 minutes long. Buenos Aires one I had a lot of time, and I was really able to give the jam introduction and then really deep dive into an aspect. And I think that is the big lesson here, is that I need a good 2 to 3 hours time slot to do what I want to do. size the Polkadot virtual machine execute, like invocation function, the lowest level of the Polkadot virtual machine. So just to give you some idea of its inputs and outputs, it accepts some amount of code. It's a Harvard architecture machine, not a von Neumann, unlike RISC-V. There's a bunch of alterations that we made, minor alterations which are trivial to...
When you have an audience, you can kind of gauge how much people are nodding and how much people are following, and if you don't see those nods, then you go a bit deeper into your explanations. But it's also very helpful if there is time, if there's time for them to ask questions, it can show you where there is a deficit in their understanding and where you need to go deeper.
So this seems to me like a base layer for optimistic rollups that actually works with permissionless fraud proofs. And maybe what is new with respect to something like Ethereum 2.0 is that it's built from ground up for that purpose.
Yeah, it's not far off the mark, and it's not doing anything dramatically different from, let's say, conceptual building blocks that are out there in the industry. I think the main difference is that it's putting them together in a particular way. Because it's part of the same protocol, we can design them with much more efficiency in mind. ETH2 is going to be held back by its desire for stability with the pre-existing protocol. It's also a little bit hamstrung with its fascination over ZK technology and the cost implications from that. Just for scaling, we don't think it makes anywhere close to sense. You're looking at around 60 to 70 million X in cost compared to executing it in a single native instance. In our case, the cost is around 30x because we execute it about 30 times. We're in Tokyo. Tomorrow there's a lecture that I'm giving at the University of Tokyo, and it's a useful sort of center of gravity, a center of mass for Asia. It's a very cultured country, Japan, very cohesive. Essentially, people seem to read social situations with a lot of conscientiousness. If for whatever reason an area is designated to be quiet, you will find that people respect that. Things work here. The system works here. And I think this is necessary because people live in such close proximity. Tokyo, I believe it's the largest metropolitan area in the world. There's a lot of automation. I mean, you see vending machines in other countries, but not like hot drink vending machines on every street corner. There are restaurants you can go to where you order your thing in a machine, it gives you a little ticket, you sit down at a booth, a hand accepts your ticket, a minute later some ramen comes out. The idea of interacting with systems and machines rather than specifically individuals is, I think, very, very natural. And even when individuals do interact, a lot of the time it comes with rules, it comes with a protocol, it's a system. This perhaps is where some of the interest stems in blockchain and crypto. It's an advanced technology. It provides for social consensus and near zero transaction cost. And it does so in an automated fashion. And this is the most automated society I've been in. Today's topic is Safrol, the block production algorithm, which is basically half of the Jam consensus algorithm. Jam splits time into 6-second time slots. I mentioned before, cores work on this 6-second thing. A work package is a 6-second sort of usage of a core. This 6 seconds is very... Thankfully, what we're doing with the grey paper is very similar to Polkadot. Most of the hard bits are already done. They're already part of Polkadot. Scope is constrained enough that we can actually deliver it in a reasonable time span. Basically, a year. And then we have E prime and M prime, which is just the same thing, except it's for this block rather than the previous block.
I believe in blockchain technology and innovative possibility for the world. It was amazing experience to listen to his talk, like face to face.
And especially like he was very honest. Whenever we asked like small question, like he took time to answer everything like detail. Even like he took like way longer than we expected to answer.
All right, are we ready to go? Yeah. All right, get the show on the road. Got to cover the stuff that I didn't get to in the last lecture in Tokyo. I wanted to get through 4 columns. I got through 1.
How many do you have to do exactly?
Depending on whether you include the appendices. I mean, you have to include the appendices really because that's part of the spec. In which case, it's 120 columns. I was probably a little bit optimistic over how fast they could be done. There we go. Yeah. That's it. Yeah, you're doing well. We're gonna go do elections, aren't we? And then, but I'm coming back. I'm going back today. Yeah. Yeah. So I'll be gone only for 12 hours. Only for 12 hours. You'll be asleep when I get back though. You'll be asleep. Then I'm not going to try and wake you up. You must have seen one. Good luck. Have a promise. Cheers.
What's she thinking about how to approach today?
Yeah, it's hard fitting it all in just a 2-hour time slot. I am learning how to explain things better and which things to emphasize and which things that don't need so much explanation. So that is evolving. The most important thing at this stage is getting people to implement correct behavior and explaining what correct behavior is. That's really what the grey paper does. They can't just write slow algorithms. They have to write algorithms that are in line with modern understanding of how to make these things go fast. We don't want this to be too much, of course, because then we're going to prejudice how they implement things, which is not what we want to do, because that could result in systemic bugs. But a few hints, tips, and suggestions can, I think, go quite a long way. Korea is sort of a well-known tech giant in Asia, so it has its accordingly fair share of good developers. It hasn't really been a big focus of Polkadot in the past, and perhaps now with the grey paper and this sort of reset to become protocol first, decentralized by design, we might be able to attract people that up till now haven't been involved. It's crucial that we do have many different implementations from the paper itself for the security of the network. Diversity of implementation, diversity of programming language, diversity of programmer, it helps increase the resilience of the network. A lot of people perhaps are under the impression that Web3 is about cryptocurrencies or Web3 is about NFTs or tokens. That's really not how I imagined the term Web3 to be used. What we're actually trying to do is to build resilient systems that are actually useful for society and can help ensure that despite potentially very disruptive circumstances that the world is moving into, these are systems that can hold up and help continue delivering the kinds of freedoms that we have grown used to over the decades.
The thing that is really interesting is that Gavin has already achieved a lot of things, but he's currently going through all the hard works that blockchains are facing. He's not taking detours, but he's going through it.
Jam is about delivering basically a resilient, decentralized computer, right? An extremely multi-core CPU that happens to be hosted by the internet.
Programming and coding is really a big industry in South Korea. For those who are looking for some problems to solve or like some projects to implement, it's a huge chance.
We want 3 implementations that can go at full speed, and we want to allow other close-by implementations to also be able to maintain the network.
Do you think people are having a try?
I think some people are giving it a jolly good try. So let's see if what comes out of it. But, you know, I get there's kind of an implementers chat channel where I do get questions. There is ongoing conversation there, people reading the paper, trying to understand it, trying to ask for clarification on some of the finer points. So there's definitely some interest, some development happening. Teaching needs to be taught, but even viewed from a more transactional, is it good for Polkadot perspective? I think even then it's very it's doing its job, which is to ensure that the ecosystem has a solid developer expertise resource to draw upon. Main thing is just to spread the knowledge far and wide and deep, and hopefully some plants will grow.
It looks like it's going to be more of a deep dive. They said that it would be like around 6 hours, so I'm getting prepared for that.
Yeah, this is a long one. The idea is that really we're going to push forward and try and get through the bulk of the paper that defines the on-chain protocol today. There is a state transition dependency graph because I wanted to make it clear that parts of the state transition can be parallelized and pipelined and so forth. The posterior time is only dependent on the header. The core has continuous work coming into it. We won't be dropping anything because we're going to be taking an item out and putting an item onto the end. We're going to remove one and add one. We're never going to overflow. Yeah. So unless 2/3 plus 1 have said that they're good, then the work reports, the hashes go into HJ, the judgment marker. Good, right. We made it to section 11. It's not quite as far as I wanted to get to, but it's good progress. So there's about 4
The availability of cores combined with the ability to produce your own block storage and logic seems like such a more advanced programmable solution as compared to smart contracts. Like it's really incredible. Plus with the scalability of it, like it's really mind-blowing.
Oh, I'm not sure what I'm going to talk about.
You should talk about similarly to the speech in San Francisco. That was very beautiful.
I can't remember, what did I say?
Then you were talking a lot of, you basically reiterated the keyboard is mightier than the sword. You did a bit of geopolitics. We did a bit of the role that blockchain plays in society. This is important because of XYZ, and you guys are the future of this. So make sure that you know this. And you know, they've done a lot of hard work and they've done good, and it's great that they're here.
I think it's worth sort of remembering why we're here. This isn't just about learning some programming APIs. It is not possible for the modern world as we know it to continue and survive, I believe, using the models, the social models of the past. And you don't have to look too far into the news to see why. This is a fairly well-known politician in the US. Our adversaries abroad and the worst actors here at home are at the cutting edge of using disinformation, less to make citizens not trust a particular person or institution, but rather not to make them trust anything. Another article. The British government said that hundreds of innocent post office workers who were prosecuted for theft, fraud and false accounting because of an IT system error will be formally exonerated on Wednesday. Many became destitute, some were imprisoned because of trust on the IT system, trust on those behind the IT system, blind trust. People's lives were destroyed. You have been taught the tools by which we can make a difference in the real world. We must also remember that resilience doesn't just come from the low-level cryptography and network operation. Resilience comes from the decentralization of expertise as well as nodes. I hope we have achieved our goal of setting you off on this journey of being able to help the world become more resilient. Thank you.
Really push towards global levels of transactive throughput. This is what Jam is, to a large extent, built as best as we can for.
The more languages and the more diversity of languages, the more diversity of implementation directions, the more diversity of how you interpret the grey paper, potentially leads to interesting optimizations or design alterations that maximize how well.
It looks, from our modeling, the machine can go very, very fast. You're looking at maybe 1 million-ish transactions a second. But there's already a pretty clear path as to how to scale beyond Jam under the same security umbrella.
One of the things that holds Web3 technologies back in general is, trying to get millions, tens of millions, hundreds of millions of people to be able to use the platform effectively. And I think Jam can really make a good step in this direction. The point of Web3 is in some sense to transcend beyond national boundaries and create a system of law, digital law, fit for a global nation. Kind of like with education. You need to go out and you need to seek. If you wait until it's delivered, you'll always end up getting the short end of the stick. You'll always end up being on the bottom, right? If you're the one that goes chasing it, if you're the one that contributes, you have so much of a better chance of ending up with a fair deal or even, on the top.
Working on the paper, so it was a bit of a big day for me, and it's 10 years and 2 days since I pushed out the yellow paper, so it's also kind of a nice anniversary. So thanks for coming and helping me celebrate it.